Hi, in this video we're going to talk about asymptotes. Alright, as you know that asymptote is a very important feature for a graph. Alright, there are many types of graph there with the existence of asymptotes. Alright, we have to use the knowledge of infinite limits and limits at infinity in finding the asymptotes of a function. Right, this is a function, right? This is a rational function, right? A rational function. So to sketch this type of graph, we have to know two types of asymptotes. Right? Two types of asymptotes, which is vertical asymptotes. Vertical asymptotes and horizontal asymptotes. Right? So we need vertical asymptotes and horizontal asymptotes. As you know that in calculus, if you want to sketch a graph, you need to know many information. You need to know all the y-intercept, the x-intercept, all the asymptotes, and even the stationary point, the turning point, inflection point. There are many information to sketching a perfect graph. So in this part, I just want to talking about the vertical asymptote and horizontal asymptote in helping us in sketching a perfect graph. Alright, so this case first I want to introduce vertical asymptote. Alright, vertical asymptotes. So vertical asymptotes, the words vertical here means is a vertical line. Alright, vertical line. So for these cases, very simple, we look at the denominator, right? For this function to be undefined, so the x cannot be 2, right? As you put value of 2 minus 2, you have 0. You have a number divided by 0, which is undefined, right? But this value is cannot accepted because the domain, right? For this case, the domain, the x cannot be 2. It can be any value of x, but cannot be 2. Alright, so means, but it is possible that the graph is approaching this line, alright, but it won't touching this line. So how? You have to learn about limits. Alright, we have to check what happened to the graph when the limit is approaching 2 plus, or we want to verify that this is an asymptote. Alright, so means that x equals to 2 may be an asymptote. So because x minus 2 cannot be 0, so x cannot be 2. So I have to evaluate the limits of 2, the infinite limits for 2 to the right and 2 to the left. So 2x over with x minus 2, right? X minus 2. So as you know that 2 plus, right? In the previous video, I have already teach you how to evaluate a limits that involving one-sided limits, right? So in this case, if you put 2, okay, you imagine that if you put 2 here, you have a positive number, right? Because 2 is a positive number, so you put 2, you have positive number. But when you put 2 minus 2, you're getting 0, right? Means a number divided by a 0. Alright, so in this video, I'm not going to talk about detail of why is it, what is happened when you divide by something near to 0. So, but I straight away tell you that you are getting an infinity. If you have a form of limits, which in the form of a over 0, means when you put the value inside here, you put 2, you get 4, but you put 2 minus 2. Okay, don't care about the 2 plus, 2 minus 2, you're getting 0, right? So, a number divided by 0, the limits of this type of value for this function is always approaching infinity. Alright, so but it can be approaching in positive or negative. So very simple. So we can, in our mind, okay, in our mind, we can know that 2 times 2 is positive, right? We know it's positive. And 2 plus means you slightly choose a number greater than 2. Slightly, okay? Don't too far. So maybe you can choose 3, right? You can try 3. 3 minus 2. 3 minus 2 is 1. 1 is a positive number. So you get positive, so you are getting a positive infinity. Okay, so then I know that limit as x approaching 2 minus. 2 minus. So I have to check to the right and to the left. Okay, what is happening when it's to the right? When the limit is 2 to the left of 2. Okay, so x minus 2 equals 2. So same thing also, you will put 2, you are getting a number, but this is a positive number, right? So in your mind, and you put 2 here, 2 minus 2, you're getting 0. A number divided by 0. 2, 2, 4, 4 over 0. Okay, you know it's infinity. Alright, so then 2, choose a number less than 2, right? Slightly less than 2. So you maybe choose 1, right? 1 minus 2, you have negative 1, right? You have negative, you know that is a negative. When you put 2 here, you have 4, right? You have 4. Okay, this one I choose 1 because you're getting 0, right? You're getting 0. So you put 2, you're getting 0. So you choose a number slightly less than 2, okay? To check the sign, okay? The sign of the outcome here. So you choose 1, okay? 1 minus 2, you're getting negative. So this one you put 2 because it won't cause it to become 0. So 2 times 2, you have 4, right? 4. So positive divided by negative, you have negative infinity. So you see, from the right, for the right of the line x equals to 2, you go into positive infinity. To the left, you're getting negative infinity. So you have verified that x equals to 2 is a vertical asymptote. Alright, it's an vertical asymptote. So how about the horizontal asymptote, right? Now we're going to teach you how to evaluate the horizontal asymptotes. So to evaluate the horizontal asymptotes, so we have to find the limit at infinity. Means when x is very big, or where is very big to the negative value, the negative, very big negative value. Alright, so then for this, what will happen? 2x over x minus 2. 2x over x minus 2. Means for this function, what will happen when the limit is at infinity? So very simple. So because you infinity in your mind, this is what type of cases in limits. So you're putting infinity, imagine you multiply 2 with a very big number, you are still getting an infinity, right? In our mind, right? So infinity minus 2, infinity is very big. It's very big, consider very big number. If you minus 2, you're still getting an infinity number. So for this type of case, we are using this polynomial, this is polynomial. We are actually applying a technique where we divide everything by the highest degree of x with the highest degree from the denominator. So where I divide everything by x, 2 over x and 2x over x. So I have limit x approaching positive infinity. This one I simplify, I have 2, 1 minus 2 over x, right? So as the value of x very big, a number divided by a very big number, you are actually approaching 0, right? Approaching 0. So when you think about 2 divided by 1, it's actually 2, right? You are getting 2. So same thing happen here also. We check what happened to the graph, to the function here when it's approaching a very big negative number. So x minus 2. So it still have the same approach. So I divide by x, x over x minus 2 over x, and this one also 2x over x. Then you have limits x approaching negative infinity of 2 divided by 1 minus 2 over x. Okay, they are exactly the same. All right. So this one will approaching 0. As you put negative infinity here, you are getting 0, right? Approaching 0. So 2 over 1, you are still getting a 2. Okay, means for positive infinity and negative infinity, the limits of this function is approaching 2. So this already tell you that y equals to 2 is a horizontal asymptote. Alright. So we have x equals to 2 is our vertical asymptote, and y equals to 2 is our horizontal asymptote. So, okay, in this video, I'm going to talk about the extra knowledge of using the vertical asymptote and horizontal asymptote in helping me to sketching a graph. Alright, let's continue the video with sketching graph. Alright, let's look at the vertical asymptote and the horizontal asymptote. So, x equals to 2 is a vertical and this is a horizontal. So, I'm sketching the graph. So, limits will tell me the direction of the graph, right? The characteristic of the graph. So, as you know that there is a vertical asymptote, vertical, right? Vertical asymptote. So, x equals to 2, the line x equals to 2 is already verified as a vertical asymptote, alright? So, and the horizontal asymptote, we have one horizontal asymptote, y equals to 2. So, means at 2 here, we have a horizontal asymptote. Okay, so what happened? Okay, this is why we calculate limits. We calculate limits. So when you limits at 2 plus means slightly, alright, more than 2, a little bit, alright, very near to 2 from the right. 2 plus means on the right. So 2 plus, it will be positive infinity, right? Means to the right little bit, it will be going positive infinity, very high, right? So I just assume it to be here. It can be very high, alright? So it means that very high above the value of y, very large, okay? So it's positive infinity. For about 2 minus 2 to the left, you calculate, you have negative infinity, right? So means it's a very negative number, negative y, right? Very negative y number. Okay, now you know the graph is, we're going up to this direction where positive infinity, negative infinity, to the left, to the right. So, as the graph approaching the line y equals to 2, because y equals to is the horizontal asymptote. So, as it go positive infinity, what is meant by x approaching positive infinity? Means the x of value getting bigger and bigger. What happened to the value of y, right? What happened to the value of y when the x is approaching very big number, 1, 2, 3, 4, up to 1,000, 1 billion, alright? So, the graph will be nearer to the line y equals to 2. This is the meaning. So, as the number getting bigger and bigger, the limits of this value will getting 2. Means this is your y will near to 2. As you see that, this is a line y equals to 2. That's why the graph will be near to 2. Right? So what happened when it's negative infinity? Right? Negative infinity. Then you know that the graph will be near to the line y equals to 2. Because you see, as x negative infinity means that the value of x negative 1, negative 2, negative 3, negative 4, negative 1,000, negative 1 billion, which is negative infinity. So the graph will be, from here, it will be moving and near to the line y equals to 2. This is the meaning. Near, when negative infinity, this value near to 2. That's the meaning of limits. So, but you know that they will intercept the y-axis, right? So, intercept y, x will be 0. So, you substitute x with 0, 0, you have whole thing to be 0. So, means they will pass through the origin. So, the graph from negative infinity here, moving up and approaching the line y equals to 2 at negative infinity. Alright, so this is the graph, which is a reciprocal function graph. Alright, so hope you understand the use of limits in finding vertical asymptote and horizontal asymptote, and hence you can sketching the graph by using all these asymptote.